friends. Today we're going to do an activity called tennis ball and ramp. You could try this at home. You're going to need a tennis ball. You're going to need some books or something to prop up a board or a piece of cardboard or a ramp of some sort. Maybe you've got ramps from like Hot Wheels or something. Those might work too. I have it on my table, but this certainly works flat on the floor. I just didn't want to put my camera on the floor today. So we will have already wrote the lab activity for this before you see this video. And then we are going to be recording this in our science journals on page 10. So I'm going to put that on my anchor chart here so that you can see all of the data, but you should be recording it in your science journal. If you would like to do this activity at home, I suggest that you stop the video occasionally so that you can try it and you can record your own data, or you're happy to record mine, that's fine too. So today what I'm going to do is we're going to be investigating how speed is related to the height of this ramp. So I have my ramp propped up in a couple books, and then I have a little basket over here that I'm going to be catching my ball in. That's not necessary for this activity. I'm just using that so I don't have to chase the ball all over the classroom again. I'm also going to use a ruler to hold my ball in place before I release it. The reason why is I don't want to add any additional energy into this system. Now there's a couple ways of doing this. I'm going to be using my phone as a stopwatch to time how long it takes for the ball to travel down the ramp and then pass this 50 centimeter mark that I put on the table. We could also do it another way. You could also release the ball and see how far it travels, and you can also measure how far it travels if you don't have an option for a stopwatch on your phone. So I'm going to release the ball first from the top of the ramp because that's what our our chart says in our science journal. And again, we're going to do this 3 times. The reason why is we want to have good data in order to support our thinking. So I'm going to go ahead and start here. And I want to make sure I hit my stopwatch at the same time as I release my ball. And I'm going to stop my stopwatch as soon as it passes this 50 centimeter mark, okay? All right, so my first one, we're going to be recording this in seconds. You'll notice this has a decimal point. In your science journal, it is centimeters. We're not going to use centimeters. We're going to use seconds today. Ooh, that's a noisy marker. So 2 minutes and 2 seconds was the first one. Let me do that again. That time it was 2 minutes, 70 seconds. I might have been a little late stopping that one. Human error. I reset. And we'll do it again. Two minutes, 36 seconds. Oh, that is very noisy. And I'll move my camera closer here in just a little bit so you can see the data more clearly. Now we're going to do the same activity, but this time we're going to release the ball from only 1/4 of the way up from the bottom of the ramp. So up here it's really, really high. It has more potential energy. Down here, it has less potential energy. So we're going to find out what happens to the speed, how fast the ball moves when it is not as far up the height of the ramp. Get my marker ready. All right, so we're going to start at about 1/4 of the way down. So that was a little bit slower. So the first one I got 2 minutes, 2.8 seconds, not minutes, excuse me. Let's do this again. Whoa. 2 minutes, 95 seconds. It's taken a little longer. I'll do that one more time. Oh, it stopped over here. It stopped it. Alrighty. So the times, and I'll move this closer so you guys can see. Maybe I'll move my chart paper this way, and then I'll move my camera up. Let's see about that. There we go. Hopefully you can see that clearly. So if you're doing this activity at home, you certainly could measure the distance instead to see how far a ball goes. The more energy it has, the more speed it has, the farther it's going to go. But in my case, I used time. So it took longer. It was not as fast when I released it from a quarter of the way from the bottom. And it was much faster, had a smaller amount of time when I released it from the top. In your science journal, we are going to skip page 11, the claim, evidence, and reasoning, and you're going to do claim, evidence, and reasoning in your science learning path for this week. Now, a claim is what happened. Well, you're going to notice which one was faster. Your evidence, you're going to pick two pieces of evidence, one from this column and one from this column to prove your claim. And then for your reasoning, you're going to explain why did that happen. Use the words potential and kinetic energy in your response. Thanks, friends. I hope you had fun.